Good morning again. My Bluetooth disconnected while I was going over problem 8. I also got a green pen because my pens are dying, so they're running out of ink. So anyways, we'll continue on. So problem 8, again, like I said, we have these vertices of a triangle F, G, and H. So I'm plotting those on a x and y axis, so -4, and then up 3. That's F. And then G is going to be at -2 and 0. And then we have H is at -1 and 4. So right about here. And we have this triangle. And then it wants it to reflect it across the y-axis. So the y-axis, again, is right here. So it's reflecting across the y-axis. So if H is at -1 and 4, it's one distance away from the y-axis going straight across. So then we're going to have it one distance to 1, 4. So H prime is going to be at 1, 4. And then G is at -2, 0. It's two distance away to the left from the y-axis. And then we're just going to count over 2 to the right. And so G prime is going to be at 2, 0. And now F is literally 4 units away from the y-axis. So then we're going to count 4 units over. So F prime is going to be at 4, 3. So we're going to draw the triangle, and it looks like that. All right, so that is problem number 8, and we are going to move on to problem number 11, which is a similar problem to problem number 8, except we're doing a translation instead. So problem 11. We have a triangle. It says A, B, C, and the vertices of A is at 0, 0, and B is at 2, 1, and then C is at 1, -3, and it wants a translation. That's what these symbols mean. They're not parentheses and they're not brackets. They're these kind of symbols. So that means we're going to translate it 3 units to the right, or in the positive direction. This is the x coordinate, and the y coordinate, we're going down, -1. So essentially, in order to do this problem, what I'm going to do right away is A prime. What we're going to do is take the x coordinate, which is 0, add 3, and then we're going to have 0 for the y coordinate and subtract 1. So A prime is going to equal 3, -1. Okay. B prime is going to be 2. We're going to add 3, and then 1 minus 1. So B prime is going to equal 5, 0. That's the new coordinate of B after translating it to the right. Okay? And now C prime is going to be 1 plus 3 and -1 minus 3. So C prime is going to equal 4, -4 after the translation. All right. So what I'm going to do, I'm just erasing problem 8 real quick to save more room. And I want to just graph it right here. So here's your x and y. So our original triangle, A prime, or A is at 0, 0. B was at 2, 1. And C is at 1, negative 3. All right, so it's right here. Once we make the translation 3 units to the right and 1 unit up, it's going to give us A primes at 3, negative 1, 3 units to the right, 1 unit down. It's going to be at 3, negative 1. So this is A prime. B is going to now be at 5, 0. So right here. So B prime is at 5, 0. And C prime is at 4, negative 4s. So our new triangle is going to be right there after we translate it 3 units to the right and 1 unit down. We're going to have the new triangle right there. All right, so that is problem 11. Again, problem 12 is identical. So I am going to allow you to work on that on your own. And now we're going to do problem 10. So problem 10, 11, and 12 are determining whether the triangles are similar. If so, write a similarity statement. Explain your reasoning. So I'm going to let you do 11 and 12, and I'm going to do problem 10 to let you have an example. So just let me erase this, and we will go from there. So problem 10 wants us to, again, determine if the triangles are similar, and then write a similarity statement. So we have this triangle right here, which is A, C, D, and then we have this little triangle right there that is B, E. And then we have 5, 7, and 3, and 9. So right away, I can look at this triangle and tell you that it is not similar. And because it is not similar, basically you can't write a similarity statement. And if you want to know where this is in your textbook, it's on page 952. So let me look at it. Okay, so I just wanted to look at the I want to look at basically what the book was saying. And what we need to do is set up a proportion. So even though I said it's not similar, the book is saying that it is similar. So what I'd like to do is try to figure this one out. It just is weird because we have this little triangle right here. And then we have this large triangle. Maybe it's just because they're not in the same direction. So if they are similar, I think what's going to happen is AB, side AB, this smaller side, is going to be equal to AD of the larger triangle. And then this hypotenuse, or this longer side of AE, is going to be equal to the longer side of the bigger triangle, which is AC. So I want to see if the proportions are equal. So AB over AD would be 5 over 10. Does that proportion equal AE over AC, which is 7 over 14? So if we look at 5 over 10, it is 1/2, and that does equal 1/2. So I was incorrect. I should have looked at the proportions to see if they were similar. The only reason I said it was not similar is because I was just looking at my hand drawing of the shape, and it just didn't look like the same. But I guess if you were to rotate this top triangle, it would have equaled out. So we could say the similarity statement is triangle ABE is similar to triangle CD. And now it wants to know why, and that's where I was like confused what the book was saying, because it said it's side angle side, but they're not giving us an actual angle. So I think the key is wrong. They do give us two sides, so I'm trying to figure out what angle though. Oh, okay, I see the angle. Sorry. It makes sense. This angle, angle A, is shared between the two triangles. And since these sides are similar and these sides are similar, it's going to be side angle side. I'm going to do the next problem with you. I have class right now. I just want to cover the next one. Again, what we have to do is determine based on proportions if the triangles are similar, even if it looks like they don't look the same because I'm hand drawing stuff. If you were to rotate ABE to the other side, it would look similar. So you just set up a proportion AB over AC, or sorry, AB over AD, because AB is the shorter side. So we want to of triangle ABC. So we want to get the shorter side of the larger triangle, which is AD, equals AE, which is the longer side of triangle ABE, and we're going to do it over AC because this is the longer side of the larger triangle. And then we set up a proportion, 5 over 10, just plugging in these values, is 7 over 14. 1/2 equals 1/2. That means that they are similar. So that's why I wrote the triangle similarity statement. And then what I had to do then is determine, well, is it side angle side? Is it side side side? What kind of congruency statement do we have, or similarity statement? And since I realized that they do share angle A, the smaller triangle and the larger triangle, we have a side, angle, and a side. Okay, so I am going to go to class, but I will post these on YouTube right now and then finish up the review later today. Anyways, have a great day, and I'll see you soon.